Hello. The following example is example 4.2.4 in your notes. Now, this is wanting us to graph f of x equals 1/2 to the x power. Again, this is an exponential function because the variable is in the exponent. The base here is this entire 1/2. In order to graph this, I'm going to want to find the three key points for 1/2 to the x power. This is how you're always going to start out. All of the x's will be -1, 0, and 1, and the y will always be 1 here with this 0. Remember, if x is -1, that means you take the reciprocal of the base. The reciprocal of the base, 1/2, the reciprocal of it is 2. And with the 1, you just keep the base how it is. So you get 1/2 from that. Remember, you're going to have a horizontal asymptote. And the horizontal asymptote in this case is y equals 0. So that's what I'm going to draw first. Notice that it's y equals 0 because I didn't have any vertical translations. So that is my horizontal asymptote, y equals 0. Then we're going to plot our three key points. -1, +2. 0, 1, and 1, 1/2. Now I'm hoping you're seeing what's happening here. It's actually going down from left to right. The previous one went up from left to right. And the reason that's happening is because your base is 1/2. In other words, for every previous one, you're multiplying your base, which is 1/2. So here was 2. 2 times 1/2 was 1. So you're going down. And then 1 times 1/2 is 1/2. Then 1/2 times 1/2 is 1/4. Then a quarter times 1/2 is 1/8. An eighth times 1/2 is 1/16, and so on and so forth. And going in the reverse direction, you multiply by the reciprocal. So 1 times 2 was 2, 2 times 2 is 4, and 4 times 2 is 8. I could go on to 16, 32, 64, so on and so forth. But there you go. And there's your exponential function. Now notice that your domain here is going to be -infinity to infinity, just like always, and your range is also here 0 to infinity. It doesn't matter that this is a decreasing function. It's still 0 to infinity.